Welcome to the Purpose Nation podcast, inspiring conversations with Christians in science, technology, and industries of the future. For more information or to make a tax-deductible contribution, visit purposenation.org.
This is Brad Cooper with Purpose Nation, and welcome to our first podcast interview of 2020. Really excited about bringing you more and more Christian leaders in science and technology and engineering in this upcoming year. So lots of exciting things going on with Purpose Nation. So thank you for joining me, and Happy New Year to all of you. For today's interview, really excited. Our guest is an engineer, and he's a husband and a dad and has all kinds of projects going on, a really great organization connecting Catholic engineers together. So just really, really excited to welcome Timothy Roemer.
Thank you. Looking forward to our conversation today.
Likewise. Now, I think you're up in the Northeast there in the New Hampshire area. So enjoying the winter. I imagine you've had a little bit of snow.
A little bit of snow, a bit of cold. We've had about 10 degrees days, so
nice.
Looking forward for the summer.
Nice. I remember those days vaguely from my days in upstate New York, but here we get down in the 40s in Southern California, so that's what we complain about when it gets cold. And so I know you have a young daughter. I think she's, 19 months old and or so. So did she enjoy the snow? Oh, I guess it wasn't her first snow. She probably had some last year, but is she getting out there and enjoying things in the snow?
She is. Yeah, my daughter Lucia really enjoys the snow. She struggles walking in it because it can be so deep at times, but she thinks it's pretty cool. She likes the snowballs. So we make mounds of snowballs and she likes playing with those.
Very cool. What other kinds of things is she into?
So it's pretty funny. My wife, Olivia, she works in gymnastics.
Oh, okay.
And our whole family on her side works and owns a gym. And our daughter spends a lot of time there. And so she, even though she's 19 months, loves the gymnastic stuff. We actually brought home one of the bars, and she's doing all kinds of things that she really shouldn't be doing at this young of an age, but she loves it. And
that's awesome. That's great. So a future gymnast, I see.
Hoping engineer, but
okay.
We'll see.
Gymnast,
maybe both.
Right? Can still do the Olympics and then go off and build things. Yeah. So and it also sounds like you just started a new job. Real quick for the folks, kind of tell us a little bit just about some of the work you do. Not necessarily maybe at the new job, but just sort of what do you do? So mechanical engineer. What are the things you work on, and what kind of work do you do?
Both of my jobs have been senior product engineer roles. So what we do with that is looking into maintaining the products that you sell. So in one case, I worked for almost 3 years in the automotive lighting industry. Your headlights, your taillights, LED, halogen. So I spent a lot of time there, and I had a mixture of projects that were related in the R&D area. One of the things we looked into is if you put different types of coatings, can you get whiter light that helps you see further down the road, makes things clearer. And the goal of that was really just safer driving. And right now, I'm now working in the advanced photonics area. And the company I work for has technologies in medical imaging. They also have scientific instrumentation and some equipment that works in the telecommunications area.
That's cool. Yeah, I definitely want to dive into a little bit more of that and some of this, kind of specific skills and things that you have and have developed. First, before we do that, a bio on Tim. And as you mentioned, he's a product engineer and been in that field for a few years. And as he said, working in advanced photonics and automotive lighting. Prior to that, and entering the engineering field, he worked as a high school STEM teacher. I think you mentioned that as well, math and physics, I guess it sounded like, as well as a part-time youth minister. He got his BS and MS in mechanical engineering from the University of New Hampshire. And as if doing all these things, isn't enough, being the full-time husband and dad and engineer, he also founded a group called Catholic Engineers. And they have a group on Facebook and have a website. Definitely want to hear a lot more about that in a minute. And he's also given talks to various Catholic groups around the country on topics like faith and science and the intersection between those two things, and has been very interested in that area. And I think I briefly mentioned it, but expecting the second in July, second child. Is that right?
Yes.
Fun times. It's a lot of fun, but a lot of work. So God bless you for that. And I also saw, now I didn't see this in the bio, but I think I may have seen somewhere you're a bit of kind of like a Jedi Knight kind of guy with like the swordsmanship.
Yeah. So
what's that all about?
Well, I've always been a Star Wars fan, and actually, my interest in sci-fi is how I got into engineering, and we can talk more about that later. But I've always loved Star Wars, and of course, you always love the Jedi. And so when I was younger, we used to fight in the backyard with broomsticks and hurt one another's fingers, pretending they were lightsabers. And when I was younger, I was like, I want to do this. I want to take lessons on sword fighting. And eventually I stumbled into fencing. And so I did fencing from, I think, middle school to the end of high school. And I picked it a little bit up in college and a little bit post-college. Time was hard to manage with family and school and work. But because my family owns a gymnastics gym, I made the offer to my father-in-law and said, hey, can I do a class that's lightsabers for the kids, but at the same time they can learn some fencing skills. And we mixed in a little bit of Ninja Warrior with it, and we call it Saber Ninja. And so it's a fun class.
That's awesome. So Catholic Engineers, tell me a little bit more about that. So you started that group not too long ago. What is it, and how did it come about?
Sure. So I started it back in December of 2014. I was actually home on Christmas break. I was in graduate school, and when I was at UNH, we had a really great Catholic student organization. And it's something I joined in my junior year, made a lot of great friends, eventually met my wife there. And as time progressed, I decided to stay at UNH for a mixture of reasons, but one was all the friends that I had in that group and the impact that group was having on me. But in my graduate program, I did not have any fellow Catholic engineers. So at that higher level of science and engineering, faith is not very common, and there's a little bit of a stigma against it. And so I found it more challenging then to kind of bring my faith into what I did, and it was almost like I had two separate lives. I had my engineering life and my Catholic friend life at church and Mass and all those great things. So when I was there, I found a Facebook page that I really enjoyed. I don't know if you've heard of it, Catholic Gentlemen.
Yeah.
They essentially focus on virtues of men and being a man and how to live out your Catholic faith. And so I really liked that page. It was something applicable to me and had a lot of great information. But it got me thinking, like, hey, it'd be great if there was like a science for Catholics or an engineering for Catholics group that I could go and follow. And I looked and looked and looked, and I found the little one-shoe-offs and I found articles online, but there wasn't something of that same substance as the group Catholic Gentlemen. And so on my Christmas break in December 2014, I was sitting at home and I had just recently listened to, I forget if it was a Scott Hahn or Bishop Barron talk about the new evangelization. And whomever it was, they had made the statement, the call isn't just for priests, it isn't just for people working in the church, it's for everyone. And the mixture of me looking for this group and that kind of nudge got me thinking, well, if I can't find it, maybe I should start it, because there's apparently a need, at least a need of one. So I started the group. It was very small, and Facebook is very interesting with the tricks you can play to get more people to like and follow things. And so eventually we grew it. Now I think we're over 5,000 likes on the Facebook page.
Wow.
There's several hundred people in the Facebook group. It seems now very active. That was a more recent ad. I've had the website for a while as well. A mixture of blog posts and information about saints that relate to science and engineering and STEM fields. Essentially trying to be a central resource for Catholics in STEM,
Right.
And to build community and show the world that, hey, Catholics can do science stuff.
Right. That's great. Well, I guess they can just go to Facebook, and we'll have a link to it, but search for Catholic Engineers on Facebook, and then the website URL is?
www.catholicengineers.org.
Easy to remember. CatholicEngineers.org. Okay.
Yeah.
Cool.
Yes,
And so mostly been kind of conversations and posting information and blog posts. And you obviously have a lot of other things going on. Like me, I tend to sign up for too many things. But anything in the kind of the coming year that you hope to expand, or you want to grow it in any way, or is it kind of where you want it to be right now?
So there's a lot I'm hoping to expand on. The big challenge is time, and right now it's kind of a one-man show.
Yeah.
But one of the things we have in the works is with the local university, my alma mater, UNH, University of New Hampshire. We are talking with the Catholic group there to maybe put on a joint faith and science interdenominational conference where we have some speakers come and kind of show the campus like, hey, look, faith and science can be compatible, and get the word out there.
Very good. Yeah, I mean, it sounds like you've had a lot of people connect, and yeah, I mean, it's kind of like the story with my wife and I and Purpose Nation, and we kind of did the same thing, exactly that you did. We just go to the web and see if we could see anything. Well, there's really nothing out there. It's kind of surprising. There wasn't a whole lot of other groups out there. I mean, there are definitely a few, and there's even more now. So I'm sure you know now there's a Society of Catholic Scientists, I think is what it's called, which is only maybe a couple years old now. Their focus, I think, is a little heavier on this, obviously, based on their name and based on your name. You're kind of more engineering, and they're kind of more focused on the sciences. But I imagine there's some overlap with those folks, right?
Yeah, I've tried to join the group several times, but I don't have a PhD in a natural science, so I haven't got.
I don't either.
I haven't got accepted.
They won't let me in either.
So one of the things that like when I think of them and what I'm kind of going for, I think of like the Knights of Malta, a very prestigious group that is hard to get into, and then the Knights of Columbus, kind of the more everyday man.
That's right.
So I'm trying to be the everyday man for the non-PhDs, and
there you go,
and build up a community that way.
Absolutely. Very cool. So I wanted to take a step back again to just your childhood and kind of growing up and what got you interested in STEM and engineering. So you mentioned the science fiction, but kind of if you can think back, what are some of the key moments for you in your life that really kind of set you off on this journey into STEM and then into engineering?
My love of Star Wars and sci-fi, it was rooted in just a wonder for creation and just the intricacies of our world around us. I've always loved to know why things happen the way they did, how things work, just that finer detail. And in a way, I've always said I wanted to be a scientist growing up. I ended up not being a scientist, I ended up being an engineer. But that was always the subject in the course that always interested me, was diving into the whys and the hows. So when I was younger, I drifted toward the science classes, and I started taking a bunch in high school. And at first I was like, yeah, I want to be a chemist. And then I started getting stuck in stoichiometry and confused and wasn't able to really see everything going on, just changes in colors. And so then I decided, all right, I'm going to be a physicist. But then the math was starting to bog me down, and I got worried. Then I wanted to be an astronomer, and I didn't want to sit in a dark room somewhere in the middle of the desert. And so eventually I kept going through all the options. And my particular high school had a program called Project Lead the Way. And this is essentially an introduction to engineering. And so they have an introductory design course that focuses on using CAD software, so like SolidWorks or Autodesk Inventor and things like that. Then they had an electronics course teaching you the basics of circuits and computer logic. And then they had one that kind of focused more on the thermodynamics and mechanics and fluids, and then a final senior design project. And so taking those courses really set me on the course of I want to be an engineer.
So, I mean, how would you describe it sort of in the differences between the science and engineering? Is kind of more of just, is it more practical application of the science, I guess? Because you still need a decent amount of math and kind of understanding, right, of physics and materials and chemistry, just maybe not as deep as you might get in being in those fields. Is that right? I mean, is that a good way to characterize it?
Yeah, I would say so. I think the big difference is the scientists might invent the new thing. They might discover the new thing. They're pushing the boundaries of the bubble of knowledge. The engineer says, all right, now that you've discovered this crazy thing, what can we make it into that helps society and people on a daily basis?
Right. Because normally when I think of a mechanical engineer, I usually think, oh, this is probably somebody who like built with Lego or something, or, you know, tore things apart or built things. Was that you or not?
So I built with Legos,
okay.
But I was not the mechanically minded tear things apart. And actually, it was funny. My dad said to me, because he was that kid growing up, he was mechanically minded, loved tearing things apart. When I was going off to my undergraduate school, he asked me if I was making the right choice, because I wasn't that stereotypical. That the mechanic, the tear apart, the electronics. I didn't really care how the thing on my desk worked. I wanted to know all the technology in it, what was kind of the theory behind it. And so what I found is in engineering, you have those two camps. You have the kind of more sciencey side engineers, and you have the more hands-on building, making a mess engineers.
Right. Got it. Okay. So did you also, I mean, were you like an artist, like graphically and kind of growing up? Did you draw things or design things?
So when I was younger, I actually took a lot of art classes. I didn't have maybe a very strong art skill set. I definitely used less of it as I got older. So for more of I'm more on the R&D side.
Okay.
So part of that, so in my undergraduate, one of the things I did that kind of set me apart from my peers is I did undergraduate research. And one of those areas that I did research in was funded by NASA, and it was looking at their MMS mission. Had a satellite that had these large, long booms. I don't remember the exact distance. It was like 42-meter length, maybe. Could be feet. I don't remember. But they were really long, thin wires. And the whole problem was when you have these thin wires way out there in space, how does the movement of the main satellite affect the sensor packages on the ends of those long, thin wires? And so we were working with a graduate student building physical models and doing some tests, programming our microcontrollers.
Cool.
So, and then I also had another deviation down the heart valve research. So I did a lot of, I had an internship in the biomedical area related to the heart and doing heart valve repair for the ventral side of the heart, the mitral valve in specific. And I also had some artificial heart valve senior project that we did in college as well. That was fun.
Okay,
nice
so
mixture of the fluid dynamics and
yeah, so I can see what you're saying. So there's
testing.
more of the kind of scientist there that's kind of looking at different scenarios and kind of trying, and that maybe haven't been tested before or done before with certain things, and kind of seeing how the mechanics of something will operate in different environments. And so you get a little bit of a mixture of existing products or things that exist versus a scientist who kind of maybe is imagining things that don't exist yet and testing them and thinking about how they handle. And so there's still kind of that questioning and wonder, even though it's about man-made things versus about nature. Maybe that's one way to think about it.
Yeah, I definitely say it's a lot of engineering is taking things that already exist and finding new ways of combining them to make something completely different.
Yeah. And so also just tell me a little bit about your Catholic Christian background. Did you grow up in a Catholic home, or sort of what's the history there?
I think it's a similar story to so many people. So I was raised Catholic. I went to Catholic school. I think around elementary school time, we had a move and we ended up falling away from the church after that move. It wasn't until in high school I had a girlfriend and she introduced me back to the Catholic faith. I got involved and I got more and more involved and invested as I moved into college and then in graduate school. And I think it was that experience of the community in college that really built up my faith. And another huge component to that was Bishop Barron. He has the Word on Fire.
Right.
And so I downloaded all of his podcasts, and I had a really long commute. And so I would just listen to those podcasts every day for about an hour one way.
Right.
And just getting all that information and knowledge really kind of built me up and set me on the right course and fed my interests. So it was a really great experience and definitely put me on the right track.
Right. And that got you somewhat more committed, it sounds like, more committed to your faith. And so for your graduate, you said you weren't. Now, was it just that there weren't any Catholics, or just wasn't any Christians in general, or maybe they were there and you just didn't know?
So in my undergrad, the exposure you get to your peers, there was so many opportunities to find other Catholics. And there was actually one of the other motivations to starting Catholic Engineers was in our group, there were, I think, 4 other engineers who were Catholic.
Mm-hmm. Okay.
And so from a large secular school, state school, to have a small group of Catholics and then at least 4th of them be engineers kind of stood out to me.
Okay.
And so, but the issue arose when I was in graduate school where you didn't get that diversity, you didn't get the raw numbers, and you get a very select group of people in a very focused area.
Right.
And so in graduate school, I definitely understand that idea of Catholics kind of keeping their Catholic identity private. And one of the goals of Catholic Engineers is to kind of flesh people out, that you're not just sitting on an island all by yourself. There are other Catholics out there that do science, that do technology, and hopefully getting people to start to crack their shells a little bit.
Right.
Maybe have a crucifix in their cube or something that kind of shows it, or whether you wear ashes to work on Ash Wednesday, whatever it might be.
Right. Start small. Yeah, at least. So, I mean, when maybe you've always been out front about it, but like in your workplace, I mean, I don't know what your experience has been, and kind of, you've been in the workplace, for a few years now. So, I mean, what has your experience been so far? I mean, I'm guessing you haven't had people say, "Oh, you're a Catholic guy." Oh, okay. I'm guessing it's mostly been positive, but I don't know. What would you say about your experience so far?
Sometimes you get those people. I actually just today had an experience where somebody noticed I had my Catholic Engineers logo on a mouse pad on my desk. And somebody asked me if that was a school that I had attended Emblem, and I mentioned it was a group that I was in. And immediately they started the discussion of the Crusades. And so I think what you need to do as a Catholic is when those opportunities come up and when somebody challenges you or asks you about your faith, that you don't shy away, that you have the discussion, you bring truth to the conversation. Because those are the experiences that they might not be expecting a response from. And those are the moments where maybe you have a potential for a conversion or a change of heart, or even open the door for a later conversation.
Right.
Because there's a lot of fallen Catholics out there in the workplace and in the world. And sometimes they just need to meet the right person and hear the right things. But if you're quiet and you hide, you're not going to be the one to help them.
Yeah, and obviously do it in love and respect, and you know,
Yes.
and hopefully not get into too deep of a debate, but yeah, to not shy away from it
But
either.
definitely keep your
Yeah.
workplace professionalism.
Right. And if they ask you, you know, that opens the door. And when someone's having a hard time, you know, ask if you can pray for them or something like that. Something as simple as that seems like in the workplace is cool. And yeah, I mean, in my workplace, in my many years, didn't really have too much pushback. But yeah, you occasionally will get somebody who might give you a hard time. But I found it to be mostly the exception. And it sounds like that's the same for the most of the guests I've had on as well. So
Yes.
talking a little bit more about engineering, and we talked about it a little bit, but I mean, if you could kind of give a little bit of a breakdown, because there's mechanical engineering and computer science, and you know, there's all kinds of different engineers. I mean, if you could give just like a real quick overview of the potential types of areas that folks could go into, young people, if they're thinking about it, they like science, they like building things, whatever they like to do, that engineering might be for them. What are the different types of engineering? Kind of maybe highlight what you do in
Sure.
mechanical engineering.
I would say there's kind of the four main types. So there's mechanical, which is what I am, and to any other engineers listening, that there is the bias of my engineering is better than everybody else's engineering. If you're an engineer in college, you see the wars. The civils get picked on by the mechanicals, and the electricals pick on everybody else, and,
Right.
and so it's all in good fun. It's all
Sure.
because we're all suffering, and we think we're suffering the most. So I'm mechanical. I actually chose mechanical specifically because it was so broad. You get a little bit of electrical, you get a little bit of chemistry, you can do a lot of different things with it. So there is that raw, the mechanics side of it, but there's also fluid dynamics, thermodynamics, all kinds of different industries wrapped into one. And so because I didn't know what I wanted to do when I got out of college, I thought that choosing the broadest field might give me the most opportunities. The next really big one is electrical engineering. You can kind of put the two in camps. So electrical engineering is covering all your circuits and the computers and telecommunications, all kinds of different cool new technologies. Definitely has a lot more math in it, and that's why I steered away a little bit from it. My math background wasn't as formidable, I would say. Another big one is civil engineering. So that's all your roads, your concrete, your asphalt, your bridges, your buildings. There's also some branch in there where there's sometimes some environmental engineering, and then the other one is chemical engineering. I mean, chemical engineering can be a mixture of biomedical, pharmaceutical, all kinds of things. Anything that really uses chemistry definitely has a big focus on manufacturing with chemicals.
Right.
And then from there, you can get into your specifics too.
Yeah, and I was just going to say, so I guess it would be an electrical, but it almost seems like it might be a fifth one, which is kind of software engineers. I don't know. I mean, that's sort of, I'm not an engineer by trade. I work with a lot of engineers, both on electrical and even some mechanical, but definitely deep in the software engineering side. And they still call themselves engineers, but they're not necessarily doing any circuitry. They're mostly just programming in a computer. But when you hear, you know, a lot of people these days, just with the explosion of computer engineering and computer science, you hear engineer now, and it almost seems like that's the go-to.
If I had to say there's an engineering field of the future, I would say electrical engineering is the category you want to be under.
Right.
And then you could say subcategories where you get more focus. There's computer engineering, so it's a mixture of the software and the hardware. And then there's the software engineering, like you mentioned. So maybe you're going to be on the more software side.
Right.
And then you got computer science where you're heavily in the programming.
Right. Now,
and so each one of those branches can do that as well. Like, so the mechanical engineering, you can have aerospace. So there's a lot of similar tools, but now you're going to focus in.
Yeah, absolutely. You know, I was going to say, too, I can imagine with all of them, even including like civil, I would imagine computers now are like ingrained, like everything else, ingrained pretty deeply in all of those. And I guess you can avoid it, but it doesn't seem like you can avoid it very much.
No, so I think a lot of the tools that engineers use are embedded in the world of computers and technology and programs. So that's why I say it's kind of the best field to be in right now, is because you have an opportunity in every industry, in every workplace, because they always need some kind of software and some kind of computer system to do something.
Right. What are some of the areas like that I'm guessing in design, I don't know if you do any 3D printing. Is there like modeling? Is there like stress testing? And what kind of things do you use computers for predominantly?
So I've used a mixture. In my undergraduate, I did a lot of the computer design, CAD software, the computer-aided design.
Right.
And so that's the 3D modeling. And whenever you make a 3D model, you usually 3D print it. And that can be from just, hey, look what I made, or it could be a functional prototype, or you can even just use it to make sure your dimensions are right and everything lines up. From a industry standpoint, there's sometimes simulation softwares. So one type of software is called finite element analysis. Essentially, you break a part down into little tiny elements, and then you can see how they act from a thermal standpoint, from a mechanical standpoint, and you can find things like stress concentrations or areas where maybe you're not getting rid of the heat as easily.
Right.
And then another thing you can do is kind of the data processing side. So that's kind of where I've been more of. So in all of our technologies, they're collecting data. So that way you can get feedback on how they're performing, or it's just the raw information that they're designed to collect. So statistics is a big area in that, and there's a lot of statistical software out there to make things run faster, and Excel is a huge component to what people do in the workplace. There's computational software like MATLAB, where you can write a program to do out some calculations and make plots and do simulations that way. So there's definitely a lot of programs and technology in the daily work that you do.
And as you mentioned, it's kind of like overlapping a lot of different areas. So math, I'm guessing some physics, talked about heat,
yes,
chemical properties, sounds like materials as well.
Yep. So, I mean, it all depends on what area you're focused in. So if your technology has a heavy influence of the materials that they're using, like I know where I am now, we use a lot of gold because of certain properties are very advantageous for us. It all depends on what your industry is.
So you recently did a lot of work in the automotive, it sounded like lighting area. So what's hot in automotive lighting? Well, it sounds like LED. I mean, LED, right?
Yep. So in the U.S., actually, we have this a little bit of a challenge right now. So to have a replacement forward light that's an LED is actually illegal. And so there's a bunch out on Amazon that you can buy and that come from overseas, but you're not supposed to be able to pop one in randomly. They're not approved for regulation.
Okay.
And
is that the main reason they haven't been approved, but will they be at some point then?
Hopefully they will be soon. Before I left my employment, I know they were working on that with the government to get approval to allow that.
Okay.
They actually have a little statement that says you have to have a filament that runs your light bulb. So an LED chip is not a filament. So fine details. But the technology is coming. It already exists, but not legally. Although unless you design a car with LEDs in it, then you can continue to use those types of LEDs. They've designed it around this government specification. So that's new. Another big one is, and this hasn't been approved yet, but it's kind of like a smart headlighting. So say if you're driving right, you want your high beams on because you get the most light. But if you have a car coming at you, you need to turn off all your high beams. Well, this technology identifies where the car is, and it only turns off certain LEDs so that way the driver on the other lane is not being blinded, but you still have all your high beams on everywhere else.
Right. That's cool. Yeah.
So and definitely the smart car stuff is kind of new and upcoming with the automatic driving and how to integrate new LED systems into that so they can interact with each other and kinds of neat things.
Okay. Well, and I noticed even in our car, our newer car, so we have an old car, and we have a newer one. The lights seem to tilt, like depending when you're turning the steering wheel. So like you said, like if so it doesn't shine, it'll shine more into the curve or the area you're going to versus like straight ahead, which isn't very helpful if you're turning a corner. So stuff like that, it seems like they've made some improvements. And so my oldest son, who's also the Star Wars fan, is also into like taillights and like the design of them and stuff like that. I don't think he's as interested in like the electrical stuff, but just how the stuff looks. That's like, I guess for some people, like for me, it's like, I just look at a car and I'm like, okay, it's got some taillights. But other people are like into the design of stuff too.
Yeah, I definitely was originally in that category of the just taillights, but after working in it for almost 3 years, also now you're watching every taillight and headlight that comes by.
Too close to the work. It's like, okay, can't turn it off. You're always looking at, that one. Yeah, and you talked a little bit about just the different skills required and things like that. So somebody is like thinking, this might sound interesting to me. I mean, what are some of the ways that you explored it? That's what you talked about it. There's a program, it sounded like in high school, where you got some exposure to it. And what would you recommend to either parents or somebody who was thinking of a career in engineering? What would be some of the things you'd recommend for them to do to kind of explore that area?
Sure. So I think the easiest place to start and the most accessible is in high school. Physics, your standard physics class, and your standard pre-calculus class, what you do in those classes is very similar to what you would be doing in college engineering. If you hated both of those classes, engineering might not be for you. I wouldn't 100% rule it out. I mean, I had my struggles. in the beginning. But if you're passionate and willing to drive through things, then you can really do anything. But those two classes really, I think, embody the approach to how you do engineering, at least from an academic standpoint. Outside of that, if you can job shadow, so if you have a family friend who's an engineer, or sometimes you can contact your school and say, hey, is there anybody that's a local company that's willing to take my child for a day or half a day? And then usually a company will allow them to follow a few engineers around, see what they do on a daily basis, the different technologies. Those are two ways, at least in high school, I think that you can really try it out. Some high schools offer engineering-like courses, so it might not be the project lead the way, but there's other opportunities. Sometimes they're homegrown courses. Some tech ed courses can kind of be engineering in nature. So there's definitely opportunities, and I would encourage anyone to try it out.
Yeah.
It's definitely, worst of cases, you come away with some neat skill that might be helpful in another industry. So
absolutely. Yeah, you're always using some kind of math or science or some kind of engineering faculties throughout daily life, even if you're not, even if you're in marketing.
Yeah, actually, at my old employment, I would say about half of the marketing team were former engineers.
Yeah.
And it's because of that strong mathematical background, the exposure to the product, and that ability to talk technically, but then also use the tools and skill set from Excel and statistical software to help out.
This issue, we kind of talked offline about it, and I know this is kind of one, the whole faith in science, quote unquote, debate and quote unquote conflict kind of issue. For you, we didn't mention it at least, but growing up, it didn't sound like, oh, I don't believe in this God thing because it doesn't kind of match with what I know about science and things like that.
So I would say from what you learn in engineering, it's not going to impact your beliefs. It's not going to turn them upside down and prove that God doesn't exist or something like that. There's no topic that really would ever bring that up. So there's no opportunity for a bias to be brought in or misinformation. In sciences, a few times I've heard concerns of parents, say in high school or middle school, they have a concern that their child learned something about the origin of the universe or about evolution, and there's some miscommunication in there, misinformation, and that's caused some questioning in their son or daughter. And so what I would encourage is to have a discussion with your child and figure out what those specific concerns, confusions, questions are that they have about a specific topic, and do the research. Find out why evolution is not an issue. Find out why our understanding of the creation of the universe is not an issue and doesn't conflict with science. And then bring those to your child and discuss them with them and gain a mutual understanding.
Was that an issue for you? It didn't sound like it.
My favorite thing is if I don't understand something, I want to understand why.
Right.
I want to understand more about it, want to learn more about it. And so luckily, it didn't hinder my faith, because when that question came up and said, oh, this doesn't make sense, there's a conflict here, I started asking the questions, I started looking online, and I was able to answer my questions. So early on, though, I would say my interest and my kind of understanding of faith and science was I could see how complex everything was and how intricate and how detailed, and it didn't make sense that it was random. It was just too intricate, too detailed, almost too designed to say, hey, this was just randomly dropped here like a set of dice and it landed perfect numbers and that we won the lottery and everything fell into place. So I think that kind of awe that I had for the world and nature and just how people grow and develop was enough to always push me and say, hey, there's something behind this. Keep looking, keep asking.
That's great. And how would you say your faith has reinforced your work and vice versa?
So work in enforcing my faith, every day I learn something new. Every day I see how detailed and intricate something is, and it just further emphasizes, hey, there's a creator out there. There's someone who lovingly designed everything around us and has a mission and a guide, and I just love kind of unraveling that and thinking to myself, hey, I'm getting a firsthand view of how God thinks, of how he designs things, and it's just so great to experience that. On the other side, how does my faith help in the workplace? There's a lot of days where, you have a hard day or you're struggling kind of with your vocational calling. And there's been a few times where I was debating whether or not I wanted to get more education or go back for a PhD. But with a young family, I kind of listened to another Catholic talk, and it was about a father who was questioning his vocation and wanted to go off and do missionary work. And he ended up talking with a religious sister And he asked her what he should do, and she said, "Oh, are you single?" And he said, "No." And she says, "Well, you married? You have kids?" And he said, "Yep, I have a daughter." And she said, "Well, your vocation is to be with your family, so go be with your family." And it kind of helped me focus on what I'm doing in my career, that my daily work, bringing home the paycheck and doing a good job, is my vocation, is to go out and work and provide for my family and protect my family and help them to be safe and happy.
Mm-hmm. Yeah, that's great. And I would say also, I mean, just using your gifts in the workplace that you're in.
Yes.
Just, hopefully designing something cool, whether it's some headlights that keep people from getting in accidents on the road or wherever you are now. Hopefully coming up with something and perfecting something that helps people too. So, yeah, and I hear that quite often. There's a lot of people I talk to who kind of are torn. They kind of want to go into ministry or, like you said, kind of go into missionary work or something like that. And they have to make that choice at some point between that and a career. And, well, the choice I've heard a lot of them make is, well, do both, which sounds like it keeps you busy. And with the family, obviously, as you said, a very important vocation. There's no reason you can't be a missionary where you are in your workplace as well.
No, I agree.
That's great. That's great. Well, awesome stuff. So God bless you and your family. And we've been talking here with Timothy Roemer. He's an engineer and also has a group called Catholic Engineers. And we'll have a link on the page, our podcast page, to their Facebook page and their website. Please do sign up with them, like them, check them out.
Thank you. Yeah, no, I appreciate that.
So I imagine you're going to be very busy preparing for the second child here over the next few months. And so are you continuing with the... I forgot what it's called. It's not the Jedi class, but it was something else. What was your class called again?
The Saber Ninja.
Probably get into trouble with Lucasfilm if you called it a Jedi class, but the Saber Ninja.
Yeah, no lightsaber, no Jedi. Keep it nice and vague.
You got to watch out for those kids, though, right? You ever get caught blindsided by... Is it a soft thing or is it like a hard sword? I mean, what kind of a sword is it?
So they're actually pretty intense. They're metal hilts. And they look just like the real Star Wars hilts, and they have a high-powered LED in them. And then they're polycarbonate tubes that light up like the lightsaber. They definitely look better at night than during the day. And so we actually have to wear kind of like a full armor suit. So we have chest protectors, elbow protectors, shin protectors, a full fencing helmet. So you're totally decked out. That's part of the fun, though. The kids just dress up and they're ready to take on the world.
Very cool, and it gives kids an excuse to whack each other, so they don't, do it in a safe environment.
Safely too.
It's been awesome talking to you. Thanks so much, Tim, for being on the podcast, and God bless you and your family and your work.
Thank you. God bless.
Thank you for joining the Purpose Nation podcast. For more great interviews, resources, or to make your tax-deductible contribution to support our nonprofit ministry, please visit purposenation.org. This program is copyright Purpose Nation, Inc., a 501c3 nonprofit corporation.